This is the Math 3 Study Guide for Unit 3. In this first problem, we are matching each vocabulary term, which is x-intercept and y-intercept, with these different things here. I guess these could be vocabulary terms if you want to say that. Okay, so this first one, here let's look at x-intercepts. X-intercepts is referring to any point on the x-axis. Honey, I have to redo it. It messed up. Okay. So those would be my x-intercepts. All of them have an x value, but the y value is 0 for all of them.
You messed up all of it?
I did. I'm trying it again, okay? Didn't work.
It's gonna take
so
forever.
This is y equals 0.
It's
That
gonna
makes
take
it
forever.
I know, honey bun. So sorry. That's gonna be.
Did come off yet?
Yes, a while ago. That means this is for an x-intercept. Zeros and roots also mean x-intercepts. Okay, this one here means x equals 0. If you think about what a y-intercept is, it's the point where x is 0, but we don't necessarily know the y value. Okay, so this one here means y-intercept. Okay, moving on. Here we are selecting the same end behavior. Okay, so in this number 2, we have an odd degree, which means opposite end behavior. Okay, and then it says a does not equal 0. That means a could be positive or negative. Okay, so opposite end behavior, positive or negative. So this one has same end behavior, so it's not A. Same end behavior, it's not B. Opposite end behavior, it does have a positive, but we can have positives. That would be fine. So C is our first answer.
1 hour and 20 minutes. Starting
now. We have opposite end behavior here. It's a negative coefficient, but we're including those. E and F are not polynomials at all. They aren't even functions. G and H have same end behavior, so those would not go in this category. So let me highlight my answer here. That is my final answer for number 2. So for number 3, we look at our highest degree term. Not use a highlighter there. And my highest degree term is a 10, so that's an even degree. And even degree means same end behavior. And again, it can be positive or negative since A is not 0. So that would be answers A, B, G, and H. Final answers. Okay, next one. Again, we're still looking at end behavior here. This one here has an odd degree with a negative leading. The leading coefficient that's a negative. Okay, so negative means it'll go down on the right, but then that 3 means it'll go opposite end behavior. Okay, here I have a negative with a square, which is down, down. So A is not a match. We have an odd and a negative, so that is a match. Here our power is 1, so it's an odd and a negative, so opposite going down to the right. And D is an odd, but the leading coefficient is positive. So the only 2 answers would be B and C. Okay, and let me highlight those. Oh, I didn't want to do it with blue pen. I wanted to do it with my yellow. Dang it, I keep doing that.
What about we do this? We put flip-flops in the flip-flop aisle. We we put shoes in the shoe aisle. That could be easy, right? Easy peasy,
Okay.
lemon squeezy.
Okay, here we have an even degree with a positive coefficient. This is an even but a negative, so that's down, down. They are not a match. Even with a positive coefficient, up, up, that's a match. Even positive coefficient, that's up, up, that's a match. See, this is an odd, that's an, no, it's going to be like this, so that's not a match. So my final answers are B and D. Is it still yellow? Yeah, okay. Figure that sucker out. Okay, here we're going to find the number of distinct x-intercepts. This one will have, I keep doing that. Here. So here our x-intercept is going to be 0, 0. This one I can factor it. I get x plus 2, x minus 2, giving me the x-intercepts -2, 0, and 2, 0. These are 3 different or distinct x-intercepts, so my 3 is my final answer. Here, this one also needs to be factored. So when I factor it, I get -1, 0, 1, 0, and -1, 0. These two, though, are the same, so I only have 2 different ones. Final answer. Here I have a 1, 0 and a 3, 0. So that's 2 different intercepts. The bounce on that square doesn't change anything. This one here is going to give imaginary roots because it's prime. Okay, so only this one will produce roots, or real roots, or x-intercepts. So when I factor it, I get x plus 3, x minus 3, giving me -3, 0, and 3, 0 as my answers, which is only 2 intercepts. Uh-oh. Oh. I'm going to erase that real quick. Okay. Next one, we are graphing. Okay, I have a couple of x-intercepts here. This first x-intercept is -2, 0. The next one is 3, 0, and the last one is 1, 0. -2, 0, 3, 0, 1, 0. Okay, the 3 will have a bounce though because of the square. And the others are going to go through. Okay, my y-intercept comes from plugging in 0 for each x value. So I end up with 2 times -3 squared times -1. -3 squared is 9, giving me a y-intercept of -18. Okay, my end behavior comes from multiplying all my x terms together. It gives me x times x squared times x, which is x to the 4th, giving me same end behavior going up on the right. Okay. Uh-oh. I need to clear that up. That's looking ugly. Try again. Okay, and I kind of missed my intercept there. Just make it a little bit bigger. Looks good. Okay. Next, intercepts here. I have 2, 0, -1, 0, 5, 0. They are all through. Okay. And then I have an x times x times x, which gives me x cubed, or odd opposite end behavior. My y-intercept here, I need to do that first. That's -2 times 1 times -5, giving me 10. Okay, I'm going to start here, down low, through, make that one a bit bigger. And I'm done. Excellent. Okay, next one. This is the factor that students tend to forget, this x one here. So we don't want to forget that one. My x-intercept there is 0, 0. It's going to go through because there's no bounce, or there's no square. -3, 0. It's also going to go through, but this 2 is going to have a bounce because of the square. Okay. Here my y-intercept is 0, and I can show you that right away. I plug in the 0 for the x, and then 0 plus 3, 0 minus 2 squared. That gives me -3 times 0 times 3 times -2 squared. I don't need to go any further because I'm multiplying with the 0. Okay. My overall end behavior comes from multiplying all of my x terms. Now I'm going to multiply the -3 too because it's attached with multiplication. So I'd go -3x times x squared, which gives me -3x to the 4th, which is same end behavior going down on the left and right. Okay, so down, down. Uh-oh. Oh, this was a bounce. Yes. Okay. Good. I knew I had to bounce somewhere. It wasn't going to make any sense. Okay. I'm just going to darken that up a little bit here. And I'll trace it with my highlighter. None of that looks good. Sorry, guys. Just fix it up here. Regular pen. Okay, good. Final answer. Next one. This one is not factored completely, so we have to factor the trinomial first. Okay, make sure you check that factoring. Okay, and that is exactly what I wanted. Okay, when I do that, I can now see that I have 2 of my x plus 5s. So I'm going to just go ahead and erase this to make more room. Okay, so I could say -5 1/5 times x plus 5 squared. And that means I'm going to have a bounce on my -5. 1, 2, 3, 4, 5. Then I'm going to go through on the 3. My y-intercept is found by plugging in 0, so -1/5 times 5 squared minus 3. 5 squared is 25. 25, -1/5 of 25 is -5. Times -3 gives me a positive 15. Okay. And then my end behavior is going to be related to this right here. So I'm going to have my -1/5 x squared times x, giving me a -1/5 x cubed. So down on the right and opposite. Okay, so.
I want to do that door. I want to do the garage door.
Yeah. Better get back outside. Daddy's not going to be out there forever. Okay. Oh, I guess I have to try that again. So GCF on this one is x squared. GCF on this one is -9. So I'm going to have x squared times x plus 4 minus 9 times x plus 4. My GCF now is x plus 4. And my remaining parts are x squared and minus 9. Then when I factor this difference of 2 squares, I get x plus 4 times x plus 3, x minus 3. Okay, let me fix that little thing in there. I should probably put my g of x equals. My x-intercepts are -4, -3, and 3. Okay, I don't know why I don't have animations on this one. Okay, this one has 3 terms, so we're doing trinomial factoring. Okay, that's when I like to do the guess and check method. So I go x squared times x squared is x to the 4th. And then I could do 2 and 2 or 1 and 4. I am going to do 1 and 4. I'm going to make it both negative because I wanted a negative 5x squared here. So if I check this, I get negative x squared, negative 4x squared, giving me a negative 5x squared, which is exactly what I wanted. Okay, so let's see here. I'm going to erase this part just so I can make room. Here I have 2 sets of difference of squares, so x plus 1, x minus 1, x plus 2, and x minus 2. Okay, so I'm going to put that down here. That gives me a lot of x-intercepts. I get -1, -2, 1, and 2. Final answers. Okay, next one here. Factoring. This one's going to be long division. Okay, this one I get to make sure I make enough room here. So I have to write smaller, I think. Okay, x cubed plus x squared minus 10x plus 8 goes here. You take the divisor goes out here. And then I'm going to do x cubed divide by x to get the first one, which is x squared. X squared times x is x cubed. X squared times -2 is -2x squared. And then we're going to subtract, but I wanted to make sure I distribute the subtraction. So when I do that, I end up with a 3x squared, and bring down the -10. Okay, then I do it again, 3x squared divided by x, that equals 3x. Okay. Okay, so 3x times x is 3x squared. 3x times -2 is -6x. I am going to distribute that negative, meaning that I'm adding. Okay, I am running out of room here. Let's see. I'm going to do my -4x plus 8. Okay, so I take the -4x, I divide by x, I get -4. I distribute my -4. -4 times x is -4x, -8. Okay, and when I distribute my negative, I get a remainder of 0, which is exactly what I wanted. Okay, then I'm not done yet. That one's factored form. Okay, and so then I would take that x minus 2, and I'm going to multiply it by that trinomial there. I'm going to erase this to make more room. Okay, that'll work. Okay, and so I'm going to have my x squared minus 3x minus 4, factor the trinomial. I'm going to have x minus 4, x plus 1. Don't forget to check your factoring. Okay, giving me a final factored form of g of x is equal to x minus 2, x minus 4, x plus 1, giving me x-intercepts of -1, 2, and 4. Final answers. Okay, finding zeros. Okay, so in this one, it wants me to factor by grouping. I have 4 terms. Okay, so I have my x cubed minus x squared minus 9x plus 9. My GCF is x squared. This one, when I factor out the 9, I have to factor out the negative also, so I have an operation here. So -9 times -1 is +9. My new GCF is x minus 1. Okay, and then I factor the difference of 2 squares. And I get those 3 factors, no plus 9, no minus 9. I do get those 2, even though this one's not listed, that's okay. They may not all be listed. It's just wanting to know which ones are factors in the list, okay? Okay, and those are my final answers there. Okay. Next one. Okay, do again, I have a trinomial and a binomial. Okay, so I'm going to take that trinomial here. Yeah, oh, that binomial is actually a difference of two squares. Okay, so not on my list, not on my list. No, nope. Ooh, this one is, yep. Nope. Yes and yes. So I have E, G, and H. Final answers. Okay, we're going to write an equation. Okay, an equation means we're not going to solve for A. So I'm going to have y, uh-oh, I did not want that. I wanted my pen. Y equals A. I'm going to have a factor for each x-intercept. X plus 3 for that one for opposite. X plus 0, and then x minus 3 for the last one. Then I go back and look for my bounces. So here's my only bounce, which means this one will have a square. These two will not because no bounce. Okay, so then I just clean it up a little bit. I don't have to have the x plus 0, so I could say y equals a x. I'm going to put a negative there because it's going down on the right. X plus 3 and my x minus 3 squared. Final answer. Okay, so I got to start that one over again. Okay, so I'm going to write the equation. I'm solving for a. Okay, y equals a. For x minus 3, I have x plus 3, x minus 5, and an x minus 2. None of them are going to have squares because it says cubic, and cubic means that it would be an x cubed or a degree 3, and right away I can see here that I would have x times x times x, which is x cubed. Okay, so if I had a square anywhere, then that would increase that number. Okay, so then I'm going to plug in my y-intercept here. Okay, and that means that the x value that corresponds is 0. So I'm going to plug in 0 for x. Okay, 10 equals a times 3 times negative 5 times negative 2. That's going to give me a negative 15 times 2 is negative 2 is 30. Divide by 30. And I'm going to get an a value of 1/3 actually. Uh-oh, I didn't want that one either. Okay, so then my final equation is a equals 1/3 x plus 3 x minus 5 times x minus 2. Okay, go with my highlighter. Oh, didn't want a blue highlighter. Do my yellow highlighter. Dang it! I have no idea what the heck I'm doing. I want yellow. It's right there. Okay. Weird. Okay, my last couple here are going to be to perform transformations on this graph right here. Let's go to my pen. So on this first one here, it wants everything to move to the right, no, left 13. Okay, so left 13, so that would go minus 13 on my x, would be negative 12, 0. The 7, let's do the 3 here. So that would be 3, that would, another 3 would be negative 9, 0, negative 9, 3. Okay, my 7, if I move it 13 that way, uh-oh, that would only be 12. I need to change that, should be negative 10. Right? Yeah. Okay. And then here, 7 minus 13 would be negative 6. Uh-oh. Okay, so that'd be negative 6, 0, and then the 5 minus 13 would be negative 8. Okay, and the pattern would be the same, so something like that. Okay, I have to remember those points there. You guys probably have them on the same sheet. Okay, so it says we're going to move everything up 25. Okay, so when I move it up 25, that 1, 0 becomes 125. That 3, 3 becomes 328. That 5, negative 4 becomes 521. Uh-oh. I think, right? Negative 4, yeah, okay. And then that 7, 0 becomes 7, 25. But I'm going to connect it with that same pattern. Okay, this next one here is a little bit more tricky. I'm going to do it in 2 phases, okay? So the first phase is, let's see if I can use a lighter color. Let's use like this lighter green maybe. Okay, so the first part says to reflect over the x-axis. Basically, we're just changing all of our y values. So that one that was 1, 0 is still 1, 0. The one that was 3, 3 is now 3, negative 3. Okay, so I'm just changing that y value. The 5, negative 4 becomes 5, positive 4. And then the 7, 0 stays 7, 0. Okay, so it just flipped though, and so it had a pattern like the one right there on 25, and so that means that arrow there would be going up and that one would be going down. So something more like that. Okay, but that's not my final answer, okay? What I need to do now, and let's take a much darker color here. This is going to be my last color. I'm now going to move everything down 52. Okay, so this one's going to now go from 1 down 52, so it would be 1, negative 52. This one would be down 52, so that negative 3 would be a negative 55. Uh-oh. Okay, that 5, 4, it's going down 52, so that would be 5, negative 48. And then that 7, 0 would now be 7, negative 52. Okay, and then it's going to connect with that same reflective pattern. Okay, if you wanted to, you could then go back and erase all of the green stuff if it's cluttered. Usually I will do one, I'll do it in pencil and then like maybe trace that one or highlight it or something like that. Okay, so I think I will highlight my final answer. Okay, and then that concludes my study guide. Hopefully that all worked out.